If you're teaching anyone anything or you're training or coaching people, you really need to be across neuroplasticity and epigenetics.
But epigenetics, what is that? For those who don't know, what exactly is neuroplasticity? Am I even asking the question correctly? And how does that relate to young athletes and skill acquisition? Hey guys, welcome to another edition of the Inside Scoop. My name is Neil Crawford. I'm your host and also the founder of Anytime Soccer Training. We have been debating brain science and the role of practice in soccer for many, many years. And like I tell you guys, I got my PhD on Google, my Master's of Science on Facebook. I'm currently attending YouTube University, and I have my opinions on this subject. But as I have promised, I love sharing my opinion, and it's just an opinion, but I want to find experts who actually know what they're talking about. And that's what I did today. And I am just so thrilled to invite Dr. Val. Dr. Val, I don't want to butcher your last name, Rytova, who's
That's right.
a behavioral neuroscientist. Welcome to the Inside Scoop. This is a well-anticipated show. You're going to bring a lot of information and knowledge to this subject to help our coaches, director of coaches who build curriculums, and our parents support their child in getting better at soccer. Introduce yourself and tell us a little bit about your work.
Thanks, Neil. Thanks for having me on the show. I'm thrilled, just as thrilled as you are. I am, as you said, a behavioral neuroscientist. What that means is I'm an expert in human behavior, things like fear-related behavior, anxiety-related behavior, social behavior, you name it, a type of behavior. I'm into it. I'm an expert at that. I'm also very passionate about things like neuroplasticity and epigenetics. And in fact, I've taken some of my research out of the lab where I teach the general public about these concepts of neuroplasticity and epigenetics, because I believe they're very, not only hot topics, but very kind of required for this day and age. If you're teaching anyone anything or you're training or coaching people, you really need to be across neuroplasticity and epigenetics. And that's why I've brought it out there to the public. I offer workshops, stuff like that. But that's look, I'm also a mom, as you know. That's a big part of my life, in addition to being a behavioral neuroscientist. That's pretty much it, Neil. That's pretty much it.
So we're going to talk a lot about neuroscience and neuroplasticity, but epigenetics, what is that?
Yeah, great. I'm glad you asked. The epigenetics is the way that our environment differentially allows for the expression of certain genes, but not others within our DNA. Said another way, it is the differential expression of our DNA according to our environment. So 99% of our DNA is actually never expressed. So you know how you get your genetics from mom and dad? Well, 99% of that actually doesn't become a protein. It never gets manifested into any behavior, like none of that. Okay. So it's just kind of, some people call it dead DNA, but it's not dead. It's actually regulating, or at least some of it, in my understanding, is regulating the parts of DNA that do code for proteins, behaviors, and are manifested into life, into reality, into the 3D, if you will. And our environment, including our social environment, our economical environment, our, spiritual, any kind of environment you can imagine, that impacts how our DNA is expressed. I'll give you an example. If you place yourself in a stressful environment, you're going to get stress genes upregulated and expressed, and you're going to get happy genes downregulated and not expressed. You with me?
I'm with you. I'm just thinking
Yeah.
my whole life.
So, and I always say it's 10% genetics, 90% environment.
Very, very interesting. Okay. So what we're going to do for this show is you were gracious enough to listen to me to a podcast I shared where I am an armchair neuroscientist and try to share my own opinion about skill acquisition. And I'm going to ask you on the record to be critical and rip me apart if you want to. because you're going to respond to some of the ideas that I shared in that podcast as we go through this very short podcast. So let's tee it up right now and say, hey, for those who don't know, what exactly is neuroplasticity? Am I even asking the question correctly? And how does that relate to young athletes and skill acquisition?
Great. So neuroplasticity is the capacity of your brain to rewire itself based on new experiences. It's the ability or the capacity of your brain to change itself based on experience. I took out the novel experience. It's just any experience. You have an experience, your brain will rewire itself.
And and so broadly speaking, practice is one of those experiences with the explicit intent of rewiring the brain.
Practice is something that strengthens what we call neuroplasticity. So once you've formed, I think neuroplasticity, this is the missing link, right? Neuroplasticity is that initial formation of the new neural pathway. When you learn a new language, when you take a new pathway to work, when you learn a new skill or, you know, a new maneuver, you're actually forming a new neural connection. I like to think about it and speak about it like an electrical circuit. You know how a circuit is? It's literally how a neuronal circuit is. It's a loop. So before you learn this new thing, that loop didn't exist. Your brain was using loops that it was used to, using for however long you've been alive, say 30, 40, 50 years or 10 years if you're a kid, right? Now, you try something new, your brain's like, oh, I haven't got a neural pathway for this, so I'm going to form one. And it does. It actually starts to form new circuits that have never been formed before. But to maintain those circuits so you can actually become somewhat proficient at that skill, you've got to reuse that new pathway because otherwise it'll disappear. The brain's a lazy thing. You see, it is a very energy hungry thing, but it's a lazy thing. It'll always go to the pathway of least resistance. It'll go to your habitual neural circuit. That's why it's so hard or difficult sometimes, especially as we get older, to form these new behaviors, to learn new things, because, we've used those old neural habitual pathways for so long that our brain's just not really into forming any new ones. I'm not saying it's not impossible. I'm saying I'm very much pro neuroplasticity. It is very much possible. That's what I'm all about. But I'll tell you what, the brain's lazy. It's going to want to use what it's used before. So when you form this new neural pathway, you're going to have to practice it in order for this new pathway to become the go-to for your brain.
Okay, so let's go to night school on this then. Why is it that a child can pick up, say, a skill in soccer a lot faster and easier than a middle-aged adult? And that
Perfect.
assumption could be wrong. Well, go ahead.
No, you're absolutely right. The reason being is that kids' brains are a lot more malleable, plastic, and they're much easily rewired than adult brains. Okay, that's one of the main differences between kids' brains. If you think about a baby up until 3 years of age, their brain's literally shaping itself. It's growing at this exponential rate. And of course, after three, kids are still learning and playing, and they've just landed on Earth, right? From wherever they were before that, and they're like, wow, I've got to learn all these things. So their brain rewires itself accordingly. Whereas after they've been on this planet for 10, 15, 20 years, we're like, okay, I know this place.
Yeah.
I know this place. Yeah. And your brain, some people say becomes hardwired. Now that's incorrect. That's erroneous. It defies the whole concept of neuroplasticity. But what I'm saying still stands. Kids' brains have a lot more malleability. They're more prone to rewiring and forming new habits, new behaviors. That's why it's so much easier for those brains. They're not, you can say they're not as lazy as adult brains. They're like, yeah, come at me. Whereas for adult brains, we're like, don't know about that one.
Okay, so now what we're going to do is we're going to talk about different forms of practice, but I'm going to use my driving class that I had in high school. let's say that the first interaction with my teacher was he was lecturing me saying, when you get to a red light, you got to look both ways. Then he gave me a handout. Let's just say he gave me a handout, and on the handout, I had the road written out, the rules of the road. Then I took a multiple choice test. I did well. Then they introduced us to a simulator where we're kind of driving, but it's like it's just visual. And then we don't have a simulator at home. I'm throwing a lot at you, so I just have to visualize driving. Maybe I'm sitting on my couch, pretending like I'm driving. Then I actually get onto the highway with my teacher, and we drive. So unpack, is there a better way of learning? Like, would it have been better for them to skip everything except just go straight to me driving in the with my instructor? Or does the theory and then leading up to the instruction help better? Or do I drive with the instructor and then go back and learn the theory? How would you think about that if you were designing a driving curriculum for a school from a
Sure.
neuroscience perspective?
Good question. Like I was saying to you before, all brains are different. The way that we learn is completely different. And what you just described is just one example of a one size fits all model. That's why not so many people pass their driving test straight away because we don't all learn the same way. And what you described is just one way of learning a task. First you go through the theory, you visualize it, then you're in a simulator, then you're in the real thing. You know how I learned? I hopped in
Yeah.
my boyfriend's car and I drove it. That's how I learned. And it was a manual. He freaked out. I freaked out, but then I kept driving and then I passed the test. So, all brains learn differently. Some people learn by through practical, physical, like that's how they learn. They have to physically touch something or like do a maneuver with their body. They're very physical. They have to really experience it in that way. And other people are really analytical and I've got a good share of that as well, being a neuroscientist. Most of the time I spend somewhere in my analytical brain. But we're all different. So I would say there has to be room for that variability or that neurodiversity within any curriculum, whether it's driving, whether it's the formal educational system. And I realize I'm someone who's been within the formal educational system my whole life. Gosh, I've got a PhD, a master's, this and that, right? I've studied a lot. But you know what? It actually worked for me to a certain extent, and it doesn't work for all people. Otherwise, we'd all have PhDs because most people are curious people, but we do not learn the same way. We just don't. And that's what I would say in response to your question.
No, that's good. So let me read this note to you, and then I'm going to ask you some questions. So I've noticed that kids don't always use the exact moves they practice in the game. And I've even seen my own sons do things they've never explicitly worked on. Now, this is going to go a little bit towards what you're saying, but I want to really unpack this because this is very soccer specific. So I've been trying to move away from the idea of learning is just about copying. But again, it's just my perspective and I don't know how the science actually works. So here's what I'm getting at that question. Okay, I have a online training company and kids, they get into the living room, they practice their ball skills, they do this, okay? One of the most common questions I always get is, Neil, show me the thing I need to do so that my kid does this exact thing in the games. And I take a step back and say, it's not so simple. First of all, because the game environment has a lot of chaos and a lot of variables. And I say the brain science, as I understand it, and that's where you're going to correct me, is effectively saying, if you practice these movement patterns and you get familiar with the ball and then you get confident, it's going to allow you to react better and learn easier and be I guess I'd say, yeah, react better and adopt and just flourish in those team environments and adapt to whatever they're throwing at you. Not necessarily a monkey see. I practice the scissors and I'm literally going to do the scissors at the right moment in the game, even though some of that may happen. I don't know if I confuse you with the question, but it's really about if I practice one skill that's soccer related, that may not translate into that same exact skill in the game. What do you say to that?
Sure. Well, I think in my response, I'll actually support what you said. So, but I'll say it anyway. What happens is when you're teaching, especially a kid who's got this malleable, plastic, kind of open brain that allows for lots of different kinds of learnings, right? When you're teaching a kid this skill in a simulation, and then they go out there in reality to play a game, the fact that they've actually learned something in a simulation has their brain be even more malleable. So it actually enhances neuroplasticity, the capacity to rewire their brain. So even if they're faced with a new situation on the court, their response time will be a lot quicker than someone who hasn't been practicing and exposing themselves to, to something in a simulation. So that's the main difference, is that if you're practicing something in a simulation, you're still stimulating the growth of new neural pathways. Now, they're not necessarily enhanced or strengthened yet because you're still a kid. You're going to have to practice this for years until it becomes your go-to maneuver, right? But you've practiced it enough that your response time, because of all that rewiring, is now a lot shorter than someone who ain't practicing in that way. Okay. And again, it depends on the person. Some people, as you say, are very visual and simulations will work well for them, whereas other people really have to use their body, get out there and play.
All right, so we got about 10 more minutes, so I'm going to get as much information from you as I can. So let's just go down one more before we go back to the practical applications of practice and stuff, and let's really go deep. Is it chemical? Is it electrons and neurons and firing that's actually sending a signal? Like literally, what is happening?
Yeah, literally, it is a neuronal pathway. So it's a bunch of neurons communicating with each other in a loop, like a circuit that, the example that I gave before. So if you can picture, I don't know, 2, 3, 4, maybe sometimes it's 100 neurons that are in a loop synapsing. So synapsing means connecting to one another. And yeah, you can imagine it as an electrical pathway. And there's a lot more to it. There's electrical signals at the end of each neuron. There's certain neurochemicals or, you know, neurotransmitters, which is a more technical word, that gets passed between the neurons. And depending on the neurotransmitter, that's where the type of neuron and the type of behavior comes in. Some of the popular ones you would have heard are dopamine or serotonin or oxytocin. Let's take serotonin, for example. That is a chemical, a neurotransmitter that gets released by neurons to enhance someone's mood, ultimately. And all that is it's released by one neuron and caught by the next neuron, and you feel happy. Okay. So yeah, on a very, very nitty-gritty neuroscience level, it's very mechanical. Like, yes, one neuron releases a bunch of particles, the next neuron catches it, and all of a sudden you're like, I feel great. Okay. So that's the neuroscience 101 of mood behavior. Or if that neurotransmitter is dopamine, then you feel really, pleasurable. You feel very, like, you can feel joy, right? So it depends on what the neurotransmitter is, but the mechanism is the same. A neuron releases a neurotransmitter, the next neuron catches it, and they're in a chain reaction. So it's like it goes on and on and on over and over again.
Okay, so now I'm gonna ask. Thank you for that. Almost like a soccer specific, but it's a sports specific question,
Sure.
kind of. Let's say I have my sons juggling with a tennis ball instead of a regular soccer ball, and literally keepy ups, whatever. What am I doing in terms of the brain?
Well, you're teaching your children, firstly, how to, well, handle that object in the way that you're teaching them. And of course, to recognize that that is a smaller object to what, one would normally use in soccer. So their brain detects that difference and alters their behavior accordingly because now they're playing with something new. Okay. And of course, neuroplasticity is happening because they have never done that before. They're like, okay, I've got to rewire my brain now for this ball.
But
Okay.
does rewiring the brain for that tennis ball translate into, okay, let's assume that juggling has some benefit because
Sure.
all my soccer wonks, I don't even want to bore you with all the qualifications I have to make. But let's
That's fine.
assume, for the sake of argument, that juggling has a benefit. Does juggling a tennis ball, because juggling has a benefit, benefit the ability to juggle your normal size ball more, or have some benefit because of the brain? And you can extend that to when you see baseball players or cricket players use different size objects to swing and all that kind of stuff. Does that have a transferable benefit?
It does. And I'll say the same thing again. You're causing neuroplasticity. So you're enhancing the capacity for your brain to rewire itself and thus react a lot faster and quicker when faced with the quote unquote real game. So when you're out there on the field after practicing all these different things with different kinds of balls or objects, you're now, you've rewired your brain, or you primed yourself for different kinds of experiences so that when you're out in the game, you're actually ready. You're more ready than someone who hasn't been practicing all that stuff because maybe they've been just following this one kind of unidirectional way of doing things. Whereas now you've exposed yourself to all these different things. So when you're out there playing, lots of, as you said before, unless you're on the court playing the game, you're doing something else. Spirit and the environment of the game is very different. So if you've done all these differential kind of trainings, different objects beforehand, you've expanded your brain or rewired your brain, or at least primed your brain, your reaction time is going to be a lot faster on the court. And that would be the main advantage in my view, because whatever comes up to you in the game, you're going to respond a lot faster, quicker, and more efficient.
So let's talk about some of the common things, because in the speed round, that are often said in youth soccer circles, and I'm going to try to get through some of them. This one is universal. I just want to get your opinion on this term. Diminishing returns, and how should we think about those? So my son can juggle 100 times. Now he can juggle 200 times. How should I think about diminishing returns when it comes to that?
So this could be translated in the neuroscience language into habit formation. So when something goes from being a novel experience and something that you practice till it actually becomes the go-to, behavior for your brain. It's kind of jam-packed, just like I was saying to you with your personality. You kind of are for yourself, Neil, and you do the things that you do just like I do. All that has to do is with repetition. So yes, a person does have to go to the brain gym and repeat that behavior over and over and over and over again until it becomes the go-to behavior for their brain. Um, and that goes across all behaviors, sports related included, right? And how long it'll take for that child to actually make this practice or this maneuver the go-to kind of maneuver for the brain really depends on the person. There's no magical like 21 day, that's not the case. Okay. I'll tell you, as a neuroscientist, there's no such thing as change a habit in 21 days. That's not true. Okay. That doesn't happen. It'll actually take however long it takes, depending on that individual. So for some people, it'll take them, 5 weeks, and other people, a lifetime.
Yes. So now let's talk about this. It's very common in youth soccer to do what we call unopposed technical training. That's
Mhm.
dribbling around cones, dribbling this kind of thing. You can picture it in basketball, any sport, doing layups without opposition. There's a practical reason to that, because literally you don't always have people around you. But there's a school of thought that says that doing this type of thing, regardless of their skill level, is categorically better and more fruitful if you can do it with opposition.
Mhm.
So you can dribble, and they'll say like cones don't move, this kind
Mhm.
of thing.
Mhm.
What is your take? Let's assume in a magical world you could always have opposition at your fingertips. What is
Yes.
your take on that?
You're going to be a real expert in neuroplasticity because I'm going to say the same thing. All brains are wired differently. So but really is the case. Some people will learn better that way, dribbling around cones with no other people because let's say there's someone who's highly susceptible to stress. So in the real game scenario, they will fold because they're under, their brain is literally in survival mode. They're not thinking straight. So for them, to actually practice without people, yes, would be beneficial. So then they're almost like on autopilot in the real game because they're so stressed out. They'll just go to these maneuvers that they've learned without other people. Whereas other people are more social beings, or maybe, they haven't had the kind of traumatic experiences other people have had around people. So they're like, yeah, I like to play with people. And that's the environment I thrive in. So that actually has to do with the thing that I said at the start, epigenetics. Your environment makes you and shapes your behavior. So for some people, an environment with other people is the preferred or the favorable environment based on how their brain is wired, but also how their DNA is. Whereas for other people, this unopposed trading may be really the go-to thing that it's going to make them an elite player. It really depends on the person. We're all wired differently. I'm telling you, there's no one way fits all.
Okay. So great. So now in wrapping this up, we've talked a lot about people being different. How in the world does someone start to know what type of brain they have, and how do they how do you do it? How do you do a self-evaluation, or is that something you guys help with, or what?
I mean, it's a great question, and it may be the missing link in different educational arenas, sports included, is really knowing yourself and knowing what works for you, knowing what style of teaching and learning works for you. Are you a classroom environment or unopposed technical training kind of person that's where you will thrive? Or are you a person that literally needs to be, a coach yelling at you 24/7 to perform? Maybe that's you. And I think we're in an era of a lot of things like personalized medicine, personalized this, that, and personalized education, baby. I'm not saying, hey, everyone needs special treatment, but you need to know yourself enough to know where you thrive and how you thrive, whether it's playing sports or learning other things like that. Yeah.
Dr. Val, I feel like I just got my first semester PhD in neuroscience.
Great.
Tell people how they can get in contact with you, and
Hmm.
tell us, we're going to flash it on the screen. They're going to see it in now, basically. Tell us about your program and how they can get involved.
Sure. Firstly, you can get in touch with me via my website, which is www.drvalrytova.com, or find me on Instagram at love_of_brain, love of brain. And yes, this amazing neuroplasticity epigenetics 101 course that I offer online. I record all sessions. You get them for life. You get my manual. So you really do get like a one-on-one in neuroplasticity and epigenetics. I run them, every couple of months. The next one's in June. So if you're really into this and you want to empower yourself with neuroscience, hop in, I say.
Thank you so much. So we put all this on the screen. Folks are looking at it now. I really appreciate your time. It's been a very thoughtful conversation. The biggest takeaway I have taken as you were talking, I was thinking about my two sons. They have totally different personalities. And one is definitely motivated by being around others more. And I have another one that just kind of wants to just focus on one thing and do his thing. And I was thinking, as a dad, I had associated the behaviors as one being more disciplined than the other one. But now, after having this conversation, I see that no, they could be just different people, different brains, different ways of learning. And I didn't
That's
think
right.
that at all.
That's right. They'll thrive. We can all thrive as long as we know, who we are in that sense.
Guys, my name is Neil Crawford. I am the host of the Inside Scoop and also the founder of the Anytime Soccer Training program. And we have sat down with Dr. Val Rytova, who is an esteemed behavioral neuroscientist, coming to us via Australia. Doctor, thank you so much for your time. And guys, let's get better together.
Thank you.